in this example, again, we check if we can cancel out any of the variables from the beginning. If I look at my x's, not the same number, same coefficient, nope. Look at my y's, not the same number, because in this y is an invisible 1. Let me write it right here. Now, even though that the y's are opposite sign, it's just going to be a different number. Now, in this case, that means we're going to have to multiply one of the equations. Be mindful, sometimes you may have to multiply to both equations in order to get the same number and opposite signs. So, even though the y's are opposite sign, I will have to multiply the second equation by 11 in order to get the y's that have the same number. But if I do that, if I multiply the 15 by 11, it's going to be a big number. Let's try to find a way where we don't have to have big numbers, therefore less work. Let's try the x's. Now the x's, they're both positive, but we know that 3 can become 6 by multiplying by 2. So if I multiply by 2, then it'll be still a smaller number, easy to work with. So let's multiply the second equation by 2. Now, here's the problem though. If I simply multiply by 2, it's still going to be a positive 6. So what I'm going to do, in order for them to have opposite sign, one must be positive, the other must be negative. So if this is going to be a positive 6, I want the second equation to have a negative 6. I'm going to multiply by negative 2. So, by doing so, negative 2 times 3x. Now, be mindful, I'm multiplying the negative 2 to the whole equation. So, repeat, I'll multiply by negative 2 to the whole equation. Negative 2 times 3x, negative 6x, negative 2 times negative 1y, plus 2y, equal negative 2 times 15, negative 30. Now I bring back the original first equation. So 6x plus 11y equal negative 9. Alright, I'm going to combine the two equations. Now you notice how my 6x and negative 6x, same coefficient, opposite sign. The x's will cancel, which is good. So now we're going to combine the y's. Positive 11y plus 2y, that's going to become 13y equal negative 9 minus 30 will be negative 39. Now I'm going to divide both sides by 13. Doing so, I'm going to get y equal negative 39 divided by positive 13 will be negative 3. So here's our first solution. Alright, second we're going to solve for x. Now again, you can choose any of the original equations. So you could choose the first one or the second one. Now let's choose the second one because it has smaller x and a y value. So I'm going to write the original, I repeat, the original equation. So 3x minus y equals 15. So what I'm going to do is I'm going to plug in negative 3 into y. But be very careful, if there's the minus, you got to keep it there. So 3x minus, now my y value is negative 3. So I'll plug in negative 3 equal to 15. So I repeat, make sure to keep that minus. It doesn't disappear even though my y value is already negative 3. So I plug in negative 3 into y. Next I'm going to simplify minus negative 3. So 3x plus 3 equals 15. From there, I'm going to solve by canceling out the positive 3. So I'm going to subtract 3 on the left, subtract 3 on the right. So 3x equal 15 minus 3 will be 12. And then in order to solve for x, I'm going to divide both sides by 3. So x will equal to positive 12 divided by 3 will be positive 4. So here's our second solution. Now if I want to write it as a coordinate point, which you can, x comes first, so parenthesis, positive 4, comma, then y comes second, negative 3, and close parenthesis, and then here's our solution, or one solution with x and y as a coordinate point.